Okay, so okay, um, okay, hi guys, welcome back to today's episode on Rust programming language. And today, what we want to talk about basically is about structs. Okay, so we want to come to the point where we understand structs, how to use it, the ways to manipulate struct, and how struct is being used in our day-to-day interactions and in real world application. So I want you to pay close attention, right, and try as much as possible to code along with me as we journey together, right? As much as possible, I will try to as much as possible I'll try to use real world examples, right, to make sure I drive this home so that we all will be able to understand it. So even if you're just barging into this tutorial, or you'll be following me along for a while, this tutorial is for you. Struct is a very powerful language and is important you learn it. So let's dive into the video and understand how to use struct and what struct is in Rust programming language, guys. So now this is a slide. All right, this slide is very just a very basic slide that we will use to illustrate what struct are and how to use it. Okay, and this is our IDE. Okay, and so in this our IDE, this is just our folder name and the folder structure. So this is how the structure of our folder. This is how what it looks like. Now basically what I did here for people that are curious to know, is just I created this folder, right, and I opened it on this IDE. So I just did cargo in it for it to instantiate the Rust binary and all those stuff here, right? So this is what I did. And if you want to do it from scratch, and maybe you want to create for scratch, what you do is just cargo new and the name of the folder. Let's say you can call it bananas, and you click enter key and it will create it for you in a minute. So just make sure that Rust is already installed on your PC. Okay, that's the most important thing. So going back to what we have today, so first of all we want to define what Rust is, what structs are, right? What are structs? Okay, so struct in Rust is a custom data type, right, that lets you group multiple related data together, right, using name fields. So this is a basic user-friendly explanation of what structs are. So this is the file. This is a simple form. So this form is called admission form, right? And in this admission form, this is the name of the form, right? And in this admission form, we have name fields. We have surname, we have name, let me zoom in. We have name, we have father's name, mother's name. For people that maybe they want to seek an admission somewhere, and maybe you went to a hospital and you need to fill a form, these are the kind of information that you need. And what these information are, they are just a related type of data that we need to understand what your need is at that particular point in time, right? So for admission form, so I want to understand who this student is, right, the name, where he's from, what his age is, right? I want to be able to understand this student. So I'm getting these form fields ready so that this student will be able to fill out this form, right? We fill out this field. Structs are is just what we use, is a format in Rust, is a custom data type that lets us group multiple related values, related data. So surname, this fields here are related because they are trying to give us an information of who we want to admit at the end of the day, right? This is what it is. This is what structs are. So going back to our code, now this is how we can be able to define a struct. We start with the keyword struct, right? And any name at all. So for this our case now, the name of this form is admission form, right? So now we want to remember struct is a custom data type that helps us to group related data types, right? So you can name this struct anything you want, any name, but the name must start with a capital letter, right? A capital letter. So let me use a user, right, with capital U and user, then with a curly bracket. So inside this curly bracket is where you will input or insert your fields. So it happens that this is just something related with tuples. We've talked about tuples in the past, right? Tuples where you can store different data types. Unlike struct you store the same data types, right? That's how struct that's how arrays works, not struct you store the same data types. The example we gave is egg, storing the same data type, example of egg, and storing different kind of stuff in a box, right? That's what we use to differentiate. If you're not watching the video, please do what to watch it, the video in this channel. So struct is quite different from tuples in the sense that you have a name and a type. In tuples, you actually access your data or your information based on the position they are, right? And so this is how we structure related data types in struct. Now the name of the field. So in our case here, this person starts with a surname. This is the name of a field. Name is the name of a field. Father's name, mother's name, card number, date of birth. These are field names. That means that they are something you need to fill out, right? So in forms they are called field names actually, and in struct also they are called field names in Rust programming language. So I need a field name, so active. So I want to know if this user is active, right? And the data type I'm using is boolean, because what you want to know is if this user is active, true or false. Are you active, yes or no? As simple as that. And also you want to get this user's username, so you want to be sure that this user has a username actually, string, right? And also you want to get the email. You want to be able to get the email of this user, right? Which you also, the email is a string, so the data type is a string. We talked about data types, right? Struct has issues with data type. You must actually provide the data type of every variable you want to actually work with in struct, right? So sign in, so just say sign in count. How many times have this user signed in? So this can work best if you're doing an authentication or a user is signing in or stuff like that, right? And this signing in it will be a number, right? An integer, right? We use u64. So how many times have this user signed in our platform? So this is typically how we actually define a struct. So with the struct name, with the keyword struct, the username, which is the name of your struct, then the fields and the data types are what will be present in between these curly brackets, right? They are what will be present in between these curly brackets. And so this is what structs looks like in Rust programming language, right? This is how structs are being defined. So we've defined this struct, and the struct name is called user, right? And this user have fields in them which are active. Is this user active? Username, email, and how many times have this user signed in, right? And also, now this is basically how struct work, and it can't get any simpler than this, right? So another thing we should talk about, that should be our concern, is now we've defined this struct, we have defined this field. So let's assume that a user wants to sign into our platform, right, and want to fill in their details. How will they do that? How is it possible? What is the format? Because this thing is just a basic. Now this is it, right? What next, right? On a normal variable, we do this. Let's say username, right? Say username. We can just explicitly add Victor, or username, right, equal to So you can explicitly add Victor here, or we can do it this way. All right, username equal string dot from, then Victor, right? So this is a better format, right? So you can be able to modify this or do anything with this. So this is how we want to, we can be able to do it on a normal variable, right? To be able to access the value, because right now this our struct has no value. What is currently available is just a field name and a data type. That's the type of value that will be stored. The value is not yet accessible by us. Now, how we can be able to access or to be able to add values to these fields, right, is what we call instantiation. You're trying to instantiate a struct. Instantiating a struct, that means you're trying to add, basic English is just that you're trying to add a very simple value to the fields, right? So this name now is user, and you're trying to add basic values. You're trying to add values. It doesn't matter any kind of value you want to add, but the fact is that you're instantiating a struct to add values to the field, right? And this is how it looks like. You use the keyword let, right, and the variable name, which is, for my case, I can use user1. You can use any name. You can use your name, right? You can use anything of your choice to input as username, provided is not a keyword that Rust compiler recognize, right? Now you said equal, then pay close attention, guys. Now the important thing is that you've getting the variable name and the let keyword. Another thing you have to do is to come here and write the user, the name of your struct, so that the compiler will know that this is the struct you're referring to. Imagine you have like 10 structs here and you didn't put this user, you just left it like this. The compiler will be confused on which struct you are trying to refer to actually. So that's why we put this actually, to be able to help the compiler work easier and faster, right? Then the name of the struct, then with the curly bracket, right? And this curly bracket here, we actually add the values we want, right? So here we say true because we are always active, right? Username will be string. Remember, what we are trying to do is to add values to this struct. We are trying to instantiate this struct called user. So from let's say someone, right? Then email can be string from, right? Let's say someone at gmail.com. Okay, so then sign count. How many times have this user signed in? Just once. You see, I've been able to sign into our system just once. So now this is how to instantiate a struct. Oops. So pay close attention. This should be a lowercase. Right? This is how to instantiate a struct. Now remember that what we did here was that we just took this name, right, and added the corresponding data types to it. So here you cannot actually go and add, let's say 45. Is an error, because why? The active here has a different data type from what you imputed here, so the compiler will frown at it. Do you understand? And the same thing applies to all this. So the data type must be in correspondence, right, with the data type of the defined struct called user, right? You must make sure of that. And so now let's close this. And this is basically how to instantiate a struct. Remember, this squiggly line, yellow squiggly line, is just a warning that we are not using this thing anywhere yet, right? And we'll use it very soon. So an analogy to explain this thing. So let's go back to our form, Yeah, this is now an example. Let me just zoom in. This is an example of a field that have been filled, right? A field that have been filled, a field with values, right? Let's start with education. Gender is male. Address. So this field has been filled. So the same way with our struct called user, the field have been filled with the corresponding values, right? So this is how struct works, right? This is how struct work. This is how we instantiate a struct. So let's say you want to actually access one of this information, right? You want to access, maybe you want to print out the username or the email or any of these values, right? So this is how we do it, right? We just let me just go here and do, oops. Okay, so I just query bracket here, then the username, the name of the variable is what we'll be going with, because now pay close attention, the variable is now the owner of this is owning this user, this struct called user, right? And it's not moving. Like when we talked about ownership, it's not applied here, because um we can actually have multiple variable that is referencing the same struct, right? And that's the beauty of it. So this is how we access this user one, which is the name of the variable, dot any name, like the names here, any name you want to actually access. I want to access the email. You can access the active, you can access the username, you can access sign in count, any of them that you prefer, right? Now the squiggly line have gone off. As you can see, the squiggly line here have gone off, and we are good to go. So why these squiggly lines are here is because we are not we are not really using this anywhere, right? The only thing we are using here is the email, right? Because this is what we define here, the email. So let's go to our this thing and just let's clear out this tab and do cargo run, right? Cargo run, and we wait for a while. And now pay close attention, this quickly line is just a warning that you're not using this thing yet, but it doesn't matter, right? If you want to use, you can add all of them inside of, you can add all of them in this print, and there will not be any squiggly line. So this is it. This is our print. This is our printed email address, right? And so for assignment sake, you can really try and see if you can implement and add. Now remember, if you're adding more values here, remember that you must add more curly brackets here, right? You must add more curly brackets here to be able to add let's say user one dot let's say oops, okay, not here. User one dot username. Okay, so if you go back to our define struct now, if you see the username have already gone off. We are now left with just these two that you've not defined yet. So for assignment, you can still try to implement this. So let's go to our terminal and run this and see what will happen. Now it printed out some, which is our username, and someone at gmail.com, which is our email address. So this is how to instantiate struct and how to use it in our code. Okay, so let's talk about a scenario where you want to modify a struct. You want to modify one of these fields. So for instance, the username or the email address you imputed was wrong, or you want to change the email address for some reasons, right? You want to change it for some reason. How do we modify struct, right? The easiest way and how it works is to add this mute keyword here. You might ask, oh, why won't we should have actually added this mute maybe here and not add it here. Remember this struct called user, right, is actually is kind of a folder that is holding all these components or all these fields, right? It's a folder that is holding all these fields. So imagine a scenario where you have a folder that is locked, right? Before you be able to modify anything, because by default you cannot modify variables, right? You cannot modify struct by default. By default it is immutable. So let's say that this folder is locked, right? For you to be able to access any file there, you must actually unlock it. So we are locking this user, struct by using this mute keyword, right? So that we'll be able to access any information you want to access. You can be able to modify any information you want to modify in this code. So let's say you want to modify the username, right? Or let's say you want to modify the email address. So let's say user1 email, right? So we want to modify it to something else. So we say string dot from, right? And you say new at gmail.com, right? So then we close this. So this is as simple as that. Like this is very simple. This is the simplest way, and this is the only way we can modify it through other means, right? But this is how it works. This is a beginner friendly way to actually modify struct, and this is the way you can modify struct. Actually, this is the way you can modify struct. Remember, our previous Gmail was someone at gmail.com, and our new Gmail should be new at gmail.com, right? So let's run this program and see what will happen. So this is our new Gmail, modified Gmail, new at gmail.com, and this is how we modify our struct. So you can decide to modify as many as possible here, right? You can decide to modify all of them, provided you have inserted this mute keyword here. Remember, by default structs are immutable. You cannot mutate struct by default. Okay, so that's a very important keynote for you to take, right? So let's try to talk about returning structs from functions, right? You're trying to return a struct from a function. How do you go about it, right? How do you go about returning a struct from a function? So we just do this, right? And we just give a very basic example of it. So what we'll do is just to let's go come up here and let's create a function called builder user, right? So you try to see if you can be able to return this function. Okay, email, right? And this email will be a string, right? And you have the username, and the username will be a string. Username will be a string. So I'll see explain why the we are actually observant about the case we are using for these names, right? So it will return a user, and yeah, we say user, which is the name of the struct. Now here we are not defining any variable, right? Pay close attention. In our case below here, we define a variable, right? We define a variable let before as inserting this user, which is the name of the struct. But here we are not giving any variable anything. What we are doing is just we are calling the user struct directly, right? And this is how we actually run it in a function. So we say active true, right? And you can say username, since the variable is here username, right? And we say email, right? And we say sign in count will be 1. Okay, so this is okay, should be a comma. Okay, so this is basically how we can be able to run struct in a function. Now we actually use the same email like this, right? Which works also. But imagine a scenario where you have a lot of these parameters in your function, right? Writing these things like this is actually confusing and is not actually a good way to write a code, right? One man said that try as much as possible not to repeat yourself in your code base, right? So this is it. So the best way to go about this, right? And this method can be called what is the name? Okay, yeah, I remember the name of this method is init shorthand, right? So this method is called not it's just a basic without any init shorthand. You're just writing it the way it is plainly. So we want to use an init shorthand to modify this for us to look a little bit professional. Okay, I hope you're good with that. So this is what you do, right? We clean up this, right? Since this is already existing, we just clean up this, right? And clean up this also. Okay, so we clean up this. So remember, there is no error because the name, the parameter here is also the same parameter here. They are sharing the same name. So instead of repeating yourself here, you just give it the usual normal user field, right? So you just give it this field here and you're good to go, right? Because the same field here, the same parameter here is the same parameter here. So that's why it's important not to use any different case sensitive, because if we use n here, right, the Rust compiler will show an error here because they don't correspond, right? Let's just test it out. They don't correspond, so there is an error here, right? And so you have to now fill this in manually, right? Okay, so yeah, now for this case we are back to normalcy, right? So this is how to define a struct in a function. So let's say that we really want to call this function, we want to return this function in our main here. So how do you go about it? Right, this is a very basic example. So okay, so what I'll do is just to wipe this thing off for us to have enough space. So we say let user one. So we will still use our, because we want to store this, this function that will be returned in a variable, right? We want to store it in a variable. That's what we want to do. So you might just use let's just use another name, Peter, I don't know. Peter equal to build user, which is the name of the variable, right? And this build user has two parameters. Pay close attention, guys. It has two parameters, right, that we want to actually call. So which is the email. So what we do here is to do string dot from, right? And let's say jen at gmail.com. Okay, so and the second parameter is username, right? The username will still be a string type, string dot from, right? From, and yeah, should still be gen fate. Okay, yeah, and we close this here, right? So we close this here. So username, oops, I didn't need to write that. So okay, so now this parameter is not in use, that's why it's actually throwing this error here, right? So this is how we return. Now you might ask, why are we not returning these ones also? Was the reason? Remember that these are they already have values, right? They already have values in them, so we can really actually access all this information, because this builder user or build user, right, is actually is carrying all these values, but this username and email does not have a value. Yes, just a parameter, All right, remember what we talked about, parameter and arguments, right? This is a parameter and we need to add the arguments here, right? And this is what we did here. So if you do print ln, so for curiosity sake, right, you might be asking how do we access these values. You can do this something like this, right? Email, we just access one of these values here and we access one of the values or one of the parameters that we return here, and also access one of the ones that we've instantiated here, right? So we just do email, okay. So the same way, right, we still call it Peter, Peter, because that's the name of our parameter. That's the name of our parameter, peter.email. Remember previously I told you us that to access it is to use the name of the variable that is storing the struct. So this builder user is storing the struct, and this Peter is storing the function, right? So we'll be accessing it through this man here called Peter. So we said email, right? So we are trying to access the email address. So this is it. So let's do print ln, and we shall try and see how we access the active, right? Active, okay. So we still do because Peter is the one accessing all our stuff, so we do active here, right? So and yeah, this is how we are able to access. Now remember, this email and this active are the ones that don't have this squiggly yellow line, because we are using them already, right? While the rest, the brothers, are not actually being used. So this is how we return functions in Rust programming language. This is how it works. So to reiterate, right, now we built this, we created this function, added a normal parameter that we normally do add in functions, right? And these parameters, this function will return a user, and this user is a struct name. So what we did here was just to call this struct here and implemented the right fields. We added the right value to the right field. So we called the name of the field and added the appropriate value, which might be true of us. And the same thing here. Now these two parameters are different. Why? Is because their parameters already, they are being represented here, and when parameters are involved in the function, the arguments are being added, the values of the parameters are being added when the function is being called. Okay, so we call the function here and we are trying to access these values, which is the username and the email address here. So we try to call one of the parameters we've implemented when we call the builder. So we accessed it here and we try to access one of the fields that we've actually instantiated here, which is this. So let's see if we are correct. So if everything works well, the email should print and the active should print, right? Let's do cargo run and let's see what we print out here. So it said email address jen@gmail.com and active is true, right? This is a very basic example. Okay, so this is how we work with function, right, in Structs. So having said that, so let's talk about something very vital, very important, right? So let's say we want to reuse values, right? We want to reuse values in our program, right? You want to reuse values in our program. How do you go about that? So we still want to go back to our previous example. So I'll just Control Z all these stuff and we'll go back to our previous examples. Okay. So so yeah, modified stuff. So I'll just Control and back to just comment this out. So yeah, what we want to do here now, okay, let's just remove this. So what we want to do here is to be able to a scenario. So let me give this example to explain all this. So let's say we have a form, right? And this form has similar information with maybe one of your friends, right? One of your friends. So instead of and the only difference between your form and that your friend's form is just the username, the name. So you are sharing the same Gmail, you are sharing the same active, how many times you guys are active, because it's your friend. Anytime you're active, even if he's not present, he's active. So I mean you do that in school, right? So sign in count. Anytime you sign in is the time your friend has signed. So the only thing that is different here is just the email address, or sorry, it's just the username. So instead of you trying to maybe, let's say that okay, let's do this. So instead of doing something like let user 2 equal, so let me just copy this, control, oops, control copy. So control C, I say control copy. So instead of doing something like this, right? So if you do something like this, it will work. Okay, it will work. Believe me, it will work. But this is very, you're repeating yourself here. Right? It's very stressful because my friend and I, we are still trying to see ourselves this information. The only difference here is just the username, right? My friend and I can share the same username. I mean, it's possible for twins actually. I don't know. I'm a twin though, sure. Now this is how it works, right? This is how it works. Now, email address, the best way, a professional way to do this is just to wipe up this, because the information that I'm sharing with a friend, what I will do is just to clean up those information here, and just clean this up, and just come below here, pay close attention, and add double colon and do user one. Okay, and the compiler will be very fine with it. Okay, the compiler will be very fine with it. And now pay close attention, guys, pay close attention, guys. Now remember that this is a string type, and string types are stored in the heap. Okay, string types are stored in the heap. And where is this? Now email address is also a string type, they are stored in the heap, while sign in count and this are stored in the stack. So heap strings that are stored in heap, because strings are always stored in the heap, right? They cannot be copied unless you enforce it by using the clone. They are moved, right? So by default, Structs ensure that you immediately you're doing this, you're moving the information from Mr. A to Mr. B, right? We talked about it previously. Now, to avoid errors, right? So now this is why this is showing an error, this user.email. Remember, this is not showing an error, right? The username is not showing an error because the username is not the same here. So what is happening here is that, pay close attention, guys. What is happening here is that the username is a move keyword, is having a move keyword. So it means that this user one now automatically doesn't have any email address, right? It doesn't have any email address. The email address have automatically been transferred from user one to user two, right? So for clarity's sake, right, let's print user one. Actually, let's print user one and see what the error is like, right? So this is what it's saying. Okay, user one dot, this is the error, right? Value borrowed here after move. All right, so the value have already been moved. So it's just saying that you're trying to borrow this information, this user, after the value have been moved. So oops. So if this is intentional, prefix it with, so this is just a very minor error because we are not using it. So prefix it so that the stuff will not keep going. So it said borrow of moved value user one, just saying that this value have already been moved. So the user one doesn't have access to this information again, right? But see the magic here. Control copy and this. So this email address will go off, the error will go off because, why will the error go off? The error will go off because the user here the only information that was transferred is this sign-in count and this active true, right? These are the two information that was actually transferred. And so by default, these informations which are stored in the stack, pay close attention. If you don't understand what the stack and the heap are, I have done a very detailed video about it. Please go and watch it and listen to it and go through that tutorial. It's very, very important. Right? This information is stored in the stack, and stack stored information can be easily copied, right? Because it can be easily copied, it is clonable, right? It's clonable by default. So copying this to here means that you are just trying to copy this two information, this two information, which is a boolean and an integer that is being stored in the stack, to this user two here, and the compiler is fine with it because this is a copied value, right? By default you can copy this value and the compiler is fine. It's a stack value can be copied. You can copy them and move your way because it's very, very easier to copy, right? It's very easier to access the information. So, and also pay close attention here also. Remember that we actually added the double colon and the user one after we've already implemented the information that we need, that is unique to us, right? Because if you copy this, if you carry this and just say place it here, right, there is already an existing error, right? There's already an existing error. So this is what we do. Because what placing it here means that you're copying all the whole value, right? You're copying all the whole value into this place, right? That's what placing this thing here means. You're copying all the whole value into this man here, and the compiler is not fine with all these friends here, right? All these friends here. So the compiler is not fine with it. Now the compiler is fine with it, but the compiler is not fine with this because all the information that is being stored in the stack are being moved. So this user one does not have any right to these informations again. So the best way to do this is to actually provide the information that are unique to you. Then you can now add this, right? You cannot add it. So what you're doing is just you're accessing, instead of you repeating yourself over again, you're just accessing this information here, the ones that are not unique to you, that are generally accepted, right? You can use it. I'm active, you're active. Maybe you are not sharing the same username, you are not sharing the same Gmail, and you can just use it here. So the compiler will be fine. So this is how Struct works, right? In Rust, it's quite a little bit strict, right? And so yeah, now the compiler is fine. So every user have a unique username, have a unique email address, and they are stored in the heap, and it is fine. The compiler is fine with it, right? And those that are stored in the stack, which are these ones, can easily be copied. So you can have different variables that are referencing one stack value. So this is it. If you're confused about Structs and heap, please go back to my video. I've done a very detailed video. When I talked about ownership, I talked about borrowing, I talked about slice. Pay close attention to those because these are they are just the core values, one of the core values of Rust programming language that makes Rust unique. Okay, now this is how structs are being used, and so let's talk about tuple structs, right? Tuple structs are very simple. They're very simple to use. So what I'll do is just to Control A and just wipe all this, right? So let's define a tuple struct. A tuple struct, right? Struct. I hope you're actually learning along, you're coding along with me, right? And we do I32, right? I32. Struct are accessed via their position, right? Struct are accessed via their position. So it's not like struct normal struct field that you access via the name, right? The name field, right? And normal struct, as I said before, I didn't actually mention that you can arrange it, assuming that the arrangement of active, right, username, email address, and sign in, right? You can, when you're instantiating, you can rearrange it anyway, anyhow you want, provided that the name field are being used. The compiler will be fine with it. Okay. So this is it. We want to see define another tuple struct point right, and I32 and I32 and I32, right? And so this is what a tuple struct looks like, right? I'm defining a tuple struct. This is what it looks like. So we do main, right? And we want to access this information, so just instantiate a struct. We want to instantiate this struct. We have to instantiate struct actually at the end of the day. So we call this color, which is the name of the struct, right? And you want to access these values. You want to ask these values are being placed based on their position. So 0 0 0. So print ln, right, black. Okay, so we do black dot 0. So let's just change this to, let's say for clarity's sake, right, 1 2 3, right? So for clarity's sake, what we are trying to access is just the 0 index. So tuple struct are index based, right? Tuple struct are index based. Why these things are showing squiggly line is because we are not using them anywhere, right? Remember, in tuple struct, you don't have to add fields to it. What we need, or what the compiler needs, is just the data type, right? And this is for the first data type. This is for the 2 is for the second data type. The 3 is for the third data type, right? And to access it, remember previously, you want to access the struct, a normal struct, right? You use the name of the variable and the field name, right? But here we use the name of the variable and the position, the current position, the value is, right? That's how we access tuple struct. So yeah, this is 1, right? It's printing 1 because we are accessing the 0 index, which is the first one. No, struct are index based, 0 index based, right? 0, right, 1 and 2. So if you want to access the second one, you still want to access the second one, you can do black dot 0 or black dot 1, right? Or just put it behind, like black dot 1, right? So you want to just argument never used, right? So let's see what's wrong with it. Okay, so the problem is that we didn't specify this curly bracket here, right? We didn't specify it, so the compiler should be fine with our code right now. So yeah, this is it, 1 and 2. Okay, so this is how we access struct, tuple struct in Rust programming language. Okay, so let's define another type of struct that is still important, that we normally use during threads, right? It's called unit-like struct, right? No field at all, right? This is what it looks like. Struct, let's say always equal, right? And yeah, this is we define this struct here. There is no field, nothing at all, right? And this is how we can instantiate it in Rust. You just do subject equals, so always equal, right? And boom, this is it. This is how we can simply define a unit-like struct in Rust programming language, right? And the compiler is very fine. It's very okay, very okay with it, right? The compiler is okay with it. And yeah, this is basically our struct and how we use struct in Rust programming language. Different types of struct. We talked about struct, talked about tuple-like struct, we talked about unit-like struct, right? And let's just write a simple code, right? A code that just summarize everything in a real world example, right? So we want to talk about how to use Struct actually in real life. Okay, use it to implement real life scenarios, real life situation where, let's say for instance, which example I'm thinking about, something random that you can just use to explain this. Okay, so imagine you're building a back end, right? You're building a back end system for a web application, okay, like Twitter or Instagram, right? You will have users, right, with username, with email, with active status and sign-in count, right? You have those users, right? So what you want to do is just to define our struct, the struct we'll be using. So the regular struct, the tuple-like struct to represent our coordinates, right? Or locations for tracking records, right? And also unit size struct, we use this for our admin. So let's just define this struct. This is just I want to just give us a real life example on how structs are being used. So remember what I said earlier is that okay, so let's just okay, user, and we say active blue, and we say username string, right? We say email, we say string, we say sign in count, say you 64, right? So you have defined our regular struct for users, right? And we want to define a topolized struct that represents our coordinates for tracking location of users or something like that, right? Just a struct coordinates, 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 right? Spelling F64 and F64, right? And we just want to unitless struct for our admin, so we just do struct admin, right? Just define the struct here like this. So this is how we go about it. You do fn. So we want to create a user. So first of all, let's define a function. So we will still use our previous functions we use. So build user, right? So email will be a string, username will be a string too, right? And it will be user. It will return a user, right? And we do user active. Okay, user active will be true. Okay, username will be empty. Let's just close this. Username will be empty. Password will be empty because we will return this stuff, right? Then count, which count will be 1, right? Okay, so you define this here, right? And so let's just define our function using and write all our codes here. So we just do fnn and just say let's user1, right, equal build user, right, and to be a string we want to return all these stuff, right? String from okay alice at gmail.com. okay, and yeah, so we'll do alice at gmail.com and we'll do string from username, right? Username will be alice 12, right? And yeah, this is it. Then you want to print users info. So you want to be able to print user info. Just to print ln. So let's print this user's information. Username. Okay, so just do user one dot username and print ln. Email. Okay, user dot user one, actually user one dot email. Okay, so let's print this. Let's just do clear. Let's let this just print our information. So you want to print out the user. So this is the user's information, email and the username and email address, right? So we've been able to achieve printing out this user's information. As you want to create another user, okay, using the struct, you want to use the struct update syntax, right, to create another user, right? The update syntax that use the dot notation, right? Instead of repeating yourself with another user, you just have to just use the dot notation to access the previous information, and you're good to go. Right? So this is what you do. Say let user2, right, equal to user, right, user, then the email, right, the email will be string dot from, right, bob at gmail.com, right, and yeah, and the rest will not be user1, right. So question, why is this not throwing an error here, right? Because it should throw an error, right? But why is it not throwing an error? Because these have already been used and dropped, right? They have already been used and dropped. But if you take this variable here, Control X, and place it here, right, there will be an error. Actually, there will be an error. So just to show you that these have already used this information and returned it back. So you'll be able to use the user one, right, and we still want to print the user one, right? We want to print the second user here, right? So just to give you a clue on how you can use this in your back end to work around user authentication and track users and all those beautiful stuff. So what I want to do is just to copy this print ln here. Just copy this, control copy, control C. I always like using control copy. So control V. I just change the print user one to user two, right, and this will be user2 at the same time. So yeah, so if you print this, let's play this and run. So the first user is Alice, and the second user is this, and Alice 2 and Bob, right? So we use the same we use different email but the same username, and other information are still the same, right? So let's try to create a location using a tuple struct, right? We want to create a location using a tuple struct. How do we go about that? This is where this becomes interesting, right? So login location, all right? We want to locate this person so that they will not be spamming our application all the time, right? Coordinates, we do 6.5244 and also do 3 points, because the information we represent above is a fraction, right? The F64 are fractions. It's just for decimal point number. For integer numbers like this that have a fraction, right, at the end of them. So remember what you're doing, we've instantiated this, and what we're trying to do is to create a user location. Okay, user's location and be able to track it. So this is just example of maybe this location is Lagos. I mean Nigeria, right? This is Lagos and this is Nigeria, right? And you're just trying to make sure that we track this and the information is correct, right? So we can do print ln, right? Login location, right? Login location will be latitude of can be latitude of anything, latitude of this, and longitude. If you do geography, you should know this. But if you don't do geography, don't worry. Those are important actually. Login, right? Dot 0. So remember that I said that accessing informations in tuple structs have to do with their position, right? Their current position has to do with their current position. So let's close this. So the first one, which is this one. So remember, this is what we did previously, was this. Oops, what's the error about? Okay. So the error was, we say we got this out together. Okay, longitude one. So let's print this out and find out. Yeah. Okay. So argument in formal string, but there is one argument. Okay. So so let's do this like this. Control X, Control V, and let's see if what will be fine with this. Okay, compiler is fine actually. So it printed out the location, right? The location is this, right? The location is the latitude is 6.5244, and the longitude is this. And just to show the login details of the location of where this person is logging in from, right? And let's talk about the tuple struct, right? Let's just define a tuple struct. Say let's underscore admin underscore maker, which is the admin, right? Admin. So we print ln and we do admin privilege granted, right? And there's an error there. Okay, we are having a double closing brackets here. As double closing brackets. I'll go wrong. Okay, so you say admin privilege granted. So this is how to use tuple structs, right? This is how to use structs actually generally, and why these men here are not actually frowning small is because we didn't use them, but you can still use them, add them in your code for data. So basically what we did there was just that, and the rundown of what we did was that we created a regular user struct here. So remember, our goal was simple. We wanted to we imagine that okay, you're building a back end, a backend system for an application, a web application, maybe Twitter or Instagram, right? And this is how the user logs in, right? Active and all those stuff. So we wanted to get the user's information. So this was for the user's location, and this is just for admin, right? And we defined a function here that returned a user, right? A struct that returned a struct, right? So this is where the struct was returned, right? And we printed it out here, and we created a user 2 that used the same data of user 1, just that the information is now different, right? And we printed it out here, and here we actually added another information, which is the location of the user that is logging in, and we printed it out here. And so here is just the admin privilege, just kind of saying admin privilege granted. So it's just a very basic something, right? For production ready, there is a lot of modification to do here, but this is a very simple example of how structs are being used, guys. So watch out on my next series. I'll talk about, very importantly, another very beautiful struct way of using structs, which is methods, actually, where we talk about implementation and all those stuff. IMP keyword, right? And please do well to go through this video again and pay close attention, subscribe. And actually, if you're in Africa, you're a developer, there is a community set out for you, right? And also, if you're in Africa and or you're in any part of the world and you are an investor or you have enough money and you want to invest, please, there is another separate group for you. It's a Telegram group, and the need or the reason why I'm creating this group is just that I want to be the link, right, between startups and investors. So this is basically my goal. So I've done a lot of research, I've interviewed a lot of people, and I found out that Africans generally are lagging behind when it comes to technology, when it comes to information, when it comes to the trends of the technology. So, and I figured out that one of the reasons is not that we are not smart, it's not that we don't know what we are doing, it's just that our ideas are dying with us because we don't have enough funding or because we don't have anybody to fund us. So I want to just be that link between investors and startups. So I want to just gather these startups and investors together. So the investor is just a name, right? You don't need to be an investor. If you have enough money or you want Africa to just be out there, you want Africans to be out there for people to see them or to be among the talked about countries or talked about nation when it comes to technology, do well to join. If you have the money, right, do well to join, because I've actually started the movement already. I call it a movement because I can't do it alone, right? It's just something that was baited out of desire to see that this nation or this continent called Africa is moving forward with other continents, with other countries, right? So please do well to join this group, right? If you've not, or if you want to join the group. Currently, YouTube is not allowing me to post links, but try and DM me. My email address is on my YouTube page, right? About me, you see my email address. You can send me a message there, or I'll drop the link in the description, in the what's it called, in the comment section below. I hope it can be accessed, but if not accessed, I'll still drop my handles, right? My YouTube, my Instagram handle, my Twitter handle, for you to just message me and I'll send you the link across, right, for you to join. Please, let's be together, let's make Africa a better place, guys. Love you guys, see you guys in my next series. Bye.